This lesson is more triangle inequalities. We have two more inequalities here that involve two triangles with two pairs of congruent sides, and we'll compare the relationships between the third side and the relationship between the included angles. The SAS inequality, or Hinge theorem, says that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle has a greater measure than the included angle in the other, then the third side of the first triangle is longer than the third side of the second triangle. That might not make perfect sense written out like that, but here's basically what it means. If you have two triangles like this, where they have a side of 3 and 3 that's congruent, a side of 5 and 5 that's congruent, then look at the included angles. Since 50 degrees is bigger than 20 degrees, then the side across from 50 degrees is bigger than the side across from 20 degrees. So if you're comparing the measure of segment AB with the measure of segment XY, since this included angle is larger, then the measure of segment AB is greater than the measure of segment XY. Now the way this works, you have to have two pairs of congruent sides. We've got 3 and 3, we've got 5 and 5. Then look at the hinge angle. That's why it's also called the Hinge theorem. If you had this hinge where it's opening up bigger to 50 degrees, and then imagine like you're closing a door a little bit. Close the door down to a 20-degree angle, and then this gap, it's bigger when it's across from the bigger angle. That's the Hinge theorem. Now the SSS inequality says something similar, but it's not exactly the same thing. It says if two sides of a triangle are congruent to two sides of another triangle, and the third side of one is longer than the third side of the other, then the angle between the pair of congruent sides in the first triangle is greater than the corresponding angle in the second triangle. So take these triangles for example. You have a congruent side of length 10 and a congruent side of length 12. Look at the third side. The third side on this triangle is 11. The third side on this triangle is 5. What this theorem says is that the angle across from the longer third side is bigger than the angle across from the smaller third side. So if we are comparing the measure of angle C with the measure of angle Z, since angle C is across from 11 and angle Z is across from 5, then angle C is greater, has a greater measure. So with each of these theorems, you have to have two pairs of congruent sides. Then what else do you know? If you know the third side, then the bigger third side is across from the bigger included angle. Or if instead you know the included angle, then the bigger included angle is across from the bigger third side.